Hello everyone. So we'll in this lecture we study steel structure part one. Okay, introduction part of our steel structure. So we start from the introduction of the steel sections that are to be studied. So from the first rolled steel section. So these are the this is the introduction of rolled steel sections. Steel structures are built with hot rolled steel sections, channel sections, and angle sections to save steel in construction works. The following sections are standardized by the Indian Standard Institution. So, first, in that section, there are many other forms of I section uh, included in that steel section. So, I'll read it one by one. ISJB Indian Standard Junior Beams, ISLB Indian Standard Light Beams, MB Indian Standard Medium Weight Beams, ISWB Indian Standard Wide Flange Beams, SC Indian Standard Column Sections. All above I sections are designated along with the depth of their respective section in mm. Example, MB 200 is a hot rolled steel medium weight beam of depth 200 mm. So here I say in the left side of the slide there is a given diagram of I section, how the I section looks. Okay, so it is a typical diagram of I section where this is flange, this is wave. Okay, and this is the breadth of the I section. I sections, they I sections include many types of different forms of the rolled steel sections, in which there are junior beams, light beams, medium mid beam, wide flange beams, column section. There are many more. Okay, so here also they have stated below that note they have given that while noting or while designating the steel section of I section in steel table or anywhere in the book or any standard format or book, they designate or they describe it as MB, and for and in front of that they give the whatever that the size or whatever that dimension of the uh, I section has, or the uh, depth of the I section what it has. Okay, so the you can see there many different types of beams and their short forms. So the depth of the beam is given in the value. The depth of the beam is given in value, and in front of the short forms that are used here. Okay, in the sections. So next is channel sections. Okay, so channel sections: ISPG Indian Standard Gate Channel, ISJC Indian Standard Junior Channel, ISLC Indian Standard Light Channel, then MC, a Indian Standard Medium Weight Channel with sloping flange, Indian Standard Medium Weight Channel with parallel flange, MCP. Okay, again all the hot rolled channel sections are designated along with the depth of the respective section. Example, MC 200 is a medium weight channel of depth 200. So here this is the diagram of channel section, how it looks. Here is the typical diagram. This is the breadth, this is the width. Okay, so this is the designation of a typical channel section. MC200 EMC is the designation of which channel section or which particular type of channel section used, and then 200 or any value in front of that short form or that designation is the depth of the channel section. Okay, so next is angle sections. Angle section: Indian standard equal angles, Indian standard unequal angles. Angle sections are designated by abbreviation ISA along with the lengths of both legs and their thickness. Example, ISA 65 by 65 by 8 mm or ISA 65 by 65 by 8 mm is an equal angle section with 8 mm thick and with both legs 65 mm long. So here on the left side they have given us the typical diagram of angle section, where this is the equal angle section and this is unequal angle section. Okay, Indian standard equal angle and Indian standard unequal angle, where A is equal to B and here A is not is equal to A is not equal to B. Okay, so they have given the designation in the format that angle section can be designated as 65 65 comma 8 ISA or ISA 65 by 65 by 8. So 65 and 65 denote the size, sorry, the length of the both legs. 65 length of A, length of B, 65 by 65, and then 8 is the thickness of the leg. Okay, so next is T section. So here in the left side they have given us the diagram of T sections. Okay, various two types of T section, which has this has broader web, this has thinner web. Okay, so Indian Standard Roll Normal T bars ISNT, Indian Standard Roll Deep Leg T bars ISDT, Indian Standard Slit Lightweight T bars ISLT, Indian Standard Slit Medium Weight T bars ISMT, Indian Standard Slit T bars from H sections ISHT. Next is so these are the types of T bars in the form of in the various dimension modifications. Okay, so next is types of structural steel and specifications. So here table 1.1 gives the various types of structural steels and their strengths. This concept or chapter is based on IS 800 1984 Indian Standard Code of Practice for General Steel Constructions. So they are from this table 1.1. They have given us the various type of steel, class of product, nominal thickness, tensile stress, yield stress. So in this column, they have given various types of steel sections. They are having the designations, or they are having tensile strength of 440, 540, 570, 590, and up to 640. Okay, so here they have the thickness. Here the class of product is given, means they where they can be used, or what are their orientation, or what are they in the form of, are given here. Okay, there may be plate sections, angle T's, beams, channels. Okay, so in these forms they are used. Okay, so here is the thickness of these standard types of steel bars. Okay, so here you can see greater than 20 to 40, greater than 20 to, here is the thickness used. Okay, so here is tensile strength. So here tensile stress again, tensile stress again, you can see the tensile stress can be denoted in the designation itself. So you can also find the tensile strength from the designation. Fe 440 it has minimum 440 of tensile strength. Then Fe 590 st, then it may have 590 of minimum tensile strength. Then it is this is ill stress, the ill stress that the bars and the ribs have in it. Okay, so here at 250 to 530. Okay, so next slide we'll go for characteristic strength. It is known that a structure is normally designed to provide safety against collapse. The failure occurs when the load acting on the structure exceed its strength. Thus, the load and the strength of the constituent material forming a structural member become the two basic design parameters which decide the safety of the structure. Since both these factors are totally independent of each other, they need separate treatment in the process of determination of safety. The characteristic strength of material is that value of the material strength below which not more than a minimum acceptable percentage of test results are expected to fall. Most of the design codes, including IS codes, prescribe the minimum acceptable percentage equal to 5% for reinforced concrete structures. It means that characteristic strength has 95% reliability, or there is only 5% probability of actual strength being less than the characteristic strength. It is a curve obtained by plotting the frequency ordinates for different assumed intervals of the quantity between range of minimum and maximum values of the given data. If the variation is normal, the curve is called a normal Gaussian distribution curve. The value of the quantity corresponding to the peak of the curve is known as mean value. So here, so here So in this characteristic strength, they have given in the introduction part that there are mainly two main things that are important while designing or while dealing with the structural member design parameters. So that is load and the strength. So load and strength are dependent on each other, and they deal with the uh, safety of the structure. So here these two basic parameters also relates with the characteristic strength of the materials. So for structure to be safe, reliable, and durable, there needs to be uh, both proper bonding between the load and the strength of the material or constituent material. Okay, so here they have stated that characteristic strength of material is is that value of the material strength below which not more than a minimum acceptable percentage of test results are expected to fall. Here means also in further line they have given that most of the design codes including IS code prescribe the minimum acceptable percentage equal to 5 percentage for reinforced concrete structure. It means that characteristic strength has 95% reliability, or there is only 5% probability of actual strength being less than the characteristic strength. So characteristic strength is basically the strength probably which is acting 95% in the favor of safety, where 95% of the 95% of the reliability is on the safety of structure, in which the strength or the durability of the structure will act in the favor of safety to the given load, and there is 5% probability of actual strength being less than the characteristic length strength. Sorry. So here is the below diagram is given, where you can see that characteristic strength value, then the 5% results below given characteristic sorry strength is given. Then this on this value there is, on the x-axis there is strength, on y-axis there is frequency density. Here you can see this is the topmost point of the curve. So from the beginning point and from the topmost mean point, we can get the point that is mean strength. So this is the mean strength value. This is the 1.64s. So okay. So next slide, we'll go for the characteristic load. A characteristic load is defined as that value of load which has 95% of probability of not being exceeded during the service lifespan of the structure. It is given by the ordinate up to which area of curve is 95% of the total area. Assuming normal distribution curve for loads, also the characteristic load Fk is given by Fk is equal to Fm plus 1.64. Yes, where Fm is the mean load of the load, mean value of the load. Yes is the standard deviation. So here they have given us the characteristic load. So characteristic load is the basically is the load which has 95% of probability which will not exceed during its service lifespan of the structure. So characteristic load is the load which will not which is acted upon a structure and which will not exceed during its lifespan of the structure, which has 95% of probability. Only 5% of probability is there of its exceeding or it's getting fail or it's getting above that. Okay, so also they have given us the normal distribution curve below that. Also here the only difference is on x-axis they have given us the load. Okay, and on the y-axis it is frequency density. So so our the 5% of results above fx is given on the right side of the mean value or topmost mean value, and characteristic load is the value from the failure or big low value of the or percent low percentage of the probability of exceeding of the load. So we go further. Partial safety factors for load and design load. Partial safety factors is a load enhancing factor greater than unity, which when multiplied to characteristic load gives a load known as design load for which the structure is to be designed. The partial safety factor for load is given by gamma F is equal to Fd upon Fk, or Fd is equal to gamma F into Fk, where Fd is equal to design load, Fk is equal to characteristic load, gamma F is equal to partial safety factor appropriate to the nature of loading and limit state being considered. The partial safety factors for loads, which is at times is simply known as load factor, depends on the type of the load and load combinations, be the type of load limit state. The values of load factors are recommended by IS 456 is given in below. So here they have for this subject or for this chapter they have suggested us to use the IS code 456 1984. Okay, sorry, 800 1984, and the partial safety factor, characteristic strength, characteristic load, all these factors are taken or standardized from the IS 456 IS code. Okay, so in this they have given us partial safety factor is a safety factor or is safety value by which the load is multiplied so as to make the structure more safe to the increasing load, or uh, where the load can increase in its service lifespan. Okay, so partial safety factor is used for the safety of the structure, which can which is to where the structure is to sustain this load by multiplying the partial safety factors. Okay, also known as design load. So there below there are given the limit state of collapse, limit state of serviceability, and there are given the load combinations. So load combinations as dead load, live load, and wind load. So there are many types of load combination. That three types of combinations they have given us, and the factors or value partial safety factors they have given us here: 1.5, 1.0, 0.8, 1.2. Okay. So partial safety factors for material strength and design strength. Partial safety factors for material strength is a strength reduction factor when applied to the characteristic strength us gives a strength known as design strength. It takes into account of differences between actual and laboratory values, local weaknesses, variation in strength, etc. Gamma m is equal to fck upon fd. The design strength is thus given by fd is equal to fck upon gamma m, where fd is a design strength, fck is characteristic strength. The partial safety factors gamma m for material recommended by IS 456 is given below. So partial safety factor for material strength is generally a strength reduction factor which is applied to the characteristic strength value and also known as design strength. So this is also a value for, or a particular value or standard value when used by for any material which differs for material like concrete and steel. Also they have given in us in the diagram that limit state of collapse partial factor is for concrete. For concrete material it is given as 1.5, and for steel material it is given as 1.5. Okay, so thank you, this was the end.